The next speaker is a Technical Director, Energy Systems, Center for Advanced Research in Building Science, CEPT, Ahmedabad. It gives me immense pleasure in welcoming Dr. Yash Kumar Shukla.
Hello everyone, I am Dr. Yash Shukla from Center for Advanced Research in Building Science and Energy at CEPT University. I want to thank the organizers at SRM Institute for inviting me to this wonderful conference. This conference has invited many esteemed guests from national and international forums and various different themes, research and practitioners themes as well. I look forward to attending many of these lectures and learning more from the lectures being presented at the conference. It also has a very, very relevant theme, which is very relevant for the domain of building energy efficiency, as well as in the domain of architecture. This icon best organized by School of Architecture and Interior Design by SRM Institute. Is going to be one of the flagship event of the country, and it will really set a benchmark for the future conferences. With that, I would like to move to my the presentation. The presentation that I'm going to talk about will discuss the low energy cooling and ventilation systems for Indian residences, and this has been developed as part of a research project that has been funded by Global Challenges Research Fund and is carried out by Loughborough University, UK, and Center for Advanced Research in Building Science and Energy at CEPT University. So my presentation topic today is low energy cooling and ventilation for Indian residences. And this project, all the strategies that I'm going to talk about has been developed as part of the research project called Low Energy Cooling and Ventilation for Indian Residences. It is an EPSRC funded project that was executed between 2017 and 2020 and it was executed by Loughborough University and CEPT University, India. We had several research partners, Alliance for an Energy Efficient Economy, AEEE, SIM, ASIC Controls, and ASHRAE, Western India Chapter, and ISHRAE, who supported us throughout the project and provided input to us. So what is the focus of our project here? The project mainly focuses on actually implementing different low energy cooling systems and ventilation strategies for India, and how it can be implemented in Indian residences. So what I thought today is about presenting you some of the findings from the research project and how it can be tangibly integrated to buildings in India, especially residences, and what are the steps that can be taken to integrate these low energy cooling and ventilation strategies in Indian residences. So I'll be talking in terms of how we can actually go about a process of designing these strategies in Indian residences. Well, historically, we have seen a lot of these strategies in our buildings. Recently, we have seen less and less adoption of these strategies. And we think that by spending more and more research time on these aspects, we can actually start integrating this in our buildings and enhancing the application of these strategies. So let me give you a background of how we look at the residential building should operate in Indian context. So we believe that mixed mode building design, where a portion of the time the building operates in natural ventilation, as well as the portion of the time the building operates in the air conditioned mode, is a way to go forward to minimize the energy impact that our growth is having in the utility grid. So mixed mode building is a very, very good potential solution that can provide thermal comfort to the occupants while using low energy in buildings. And as I explained, it uses a combined use of natural ventilation and mechanical cooling in buildings. And what we have found is that while we have historically seen a lot of these strategies, in the newer context, in the modern context, there needs to be a sophisticated installation strategy as well as the sophisticated operation strategy for effective operation of mixed mode buildings. And there needs to be a lot of work that needs to be done to help implementation of these strategies. So let me start with the concept of adaptive thermal comfort model. So through our historical research, we have found that we don't have to maintain a constant indoor temperature in buildings, especially in various parts of India. And if you compare on the x-axis, there is an outdoor temperature running mean. That means that how the temperature of outdoor is changing in last 30 days. And at what temperature, neutral indoor temperature, people feel comfortable. And you can see that the black solid line shows the neutral temperature observed by ASHRAE. And you can see that as the temperature increases, you can actually maintain a slightly warmer temperature as high as 26, 27 degrees and still keep people comfortable. Now, when we did the same research in Indian context, we found that there is a solid red line where the adaptation is even more in tropically acclimatized occupants. So you can even maintain a slightly warmer temperature in buildings and make people comfortable. So that is the model, adaptive model that you can be used to keep people comfortable in residential buildings in India. Now, how do we use that in a specific city scenario? So if we apply this in for a city of Ahmedabad, this is what we get. And you see the light blue line or the area, it shows that the band of comfort at which people will feel comfortable in different times of the year. So as you move from January to May, June, July, August, September onwards, you can see that you can slightly maintain higher temperature inside the building and still keep people comfortable inside the building. And the light blue band is where the 90% of the occupants are comfortable. Now, if you allow a little bit more wider bands to be maintained inside the building, you can actually maintain a slightly higher temperature as high as 29, 30 degrees and as low as 17, 80 degrees where people feel comfortable. So how does this help? So the looser the band is, more flexibility is which is allowed inside the building in the temperature, maintaining the temperature conditions, it gives more opportunity for the designers to integrate different strategies inside the building. So this is why adaptive thermal comfort model and India model for adaptive thermal comfort is very, very good for application in Indian residences. So when we start integrating that into our buildings, we start with a climatic data analysis. So first you look at different cities. So this slide shows 8 cities across India, and we have analyzed that what is the natural ventilation potential, which is in the orange bar here for different cities. And you can see that in even in a city like Hyderabad, there is a significant number of hours you can operate our building in natural ventilation. So the outside climate is favorable for natural ventilation. However, there are times, as you can see on the blue lines, the blue bars, that you cannot operate the buildings in natural ventilation throughout the year. There are periods when you will need active cooling systems to operate. So at that point, you will actually have to rely on active air conditioning systems such as mechanical cooling systems. That's why you need to use a strategy which is a mixed mode ventilation and cooling, so that whenever outside is comfortable, you use it during this orange bar period, and whenever outside is not comfortable, you actually have to start using an active air conditioning system. So once you do the climatic analysis of your city, you first try to find out that what should be my opening sizes in my residences. So then you actually do a ventilation rate analysis. So you calculate the um, uh, uh, amount of flow rate, outdoor air flow rate you need in your building, in your bedrooms, in your spaces to remove the heat generated by the spaces. So even though outside environment or conditions are comfortable, you still need certain airflow to come inside the space and a sufficient quantity of air inside the space to take away the heat from the space. So that's why you need to start thinking about designing the opening of your open windows. So this table here shows that for Ahmedabad, Delhi, and Mumbai, if you design your space for certain airflow rate, air exchange rate, or airflow rate, what should be my ideal airflow rate that I need to remove 75% of the time when natural ventilation is working or outside the environment is comfortable. If I want 75% of those hours to be used in my building, what should be my airflow rate? So that's the first part in deciding that, okay, what should my airflow rate design should be for this city that I'm building my residences into. And then you go, once you design that, once you decide that this should be my airflow rate, then there is a design charts given for each strategies to size the opening area in your residences. So here you can see that on the x-axis, you have an airflow rates that you would like. And on the y-axis, you will see what is an effective area opening that you need. So this will help you decide that what is my area that I need to design for my cities. And you can see here in Mumbai, Delhi, and Ahmedabad, there is a line which shows what is a business as usual area that we observed in our research, and what would be an ideal opening area that we need from 1 to 2 meters square of opening area we need to provide sufficient quantity of air for ventilative cooling, to provide sufficient cooling in the space. So this is where you start. Once you design, you understand the climate, you decide the airflow rate, then you go and find out, identify what's the area that I need in my residences. Once you know the area, then you start designing your specific window and openings. Depending upon the type of window you have, whether you have a sash window, whether you have a single balcony door that you are planning to use for ventilation, or your casement window, your actual opening area, effective opening area will vary. So accordingly, you can size, and depending upon your design of your residences and spaces, you can select what window type you need. But all you need to worry about is that my total effective opening area should match the area that I have identified in the earlier step. So once you have identified the opening area, the next step would be for your residences and ventilation cooling strategies would be to say what strategies I need to integrate with my natural ventilation. So the natural ventilation part, once you have designed, you need to think about how do I use my mechanical cooling systems when outside is not comfortable. How do I integrate the both? So what would be my mixed mode operation mode? So these slide shows a different way of operating your building. So on the first part, which is A, this is a concurrent mixed mode where you are operating the natural ventilation as well as air conditioning together. Or on a hot day, you will actually turn off the windows and you will actually just run the air conditioning system. The other strategy is a zoned mix mode. In a zone mix mode strategy, you divide a certain zone of your building, which is an interior zone, where you continuously operate the air conditioning system. But whenever the peripheral zones where you can still take an advantage of natural ventilation, you continue to operate in the natural ventilation mode. So B is the part which is showing you a zoned mix mode design. So depending upon what your building strategy is, what your building design is, you can actually start designing your ventilation cooling strategy and select what mode of operation you want for your building. Once you have identified the strategies, the next thing would be to selecting the low energy cooling systems. And this chart shows you how to go about designing your low energy cooling systems. So if you look at the x-axis in this slide, it shows the energy consumption of your air conditioning systems per meter square of area, which is called EPI. And the y-axis shows the percentage of comfortable hours that you would likely to expect in that space. On the rightmost top box that you see here, you can see that DX refrigerant coil direct expansion system, which is the most typical air conditioning systems used in our residences, tend to provide a very high comfort, but it uses a lot of energy, almost as high as 90 EPI in our spaces. When we start going into a little bit more hybrid kind of a system, we actually can go to a medium comfort and low energy systems where you use, indirect evaporative coolers or two-stage direct or indirect evaporative coolers, where you significantly reduce your energy consumption of your space, but you also reduce your comfortable hours. So there's a little bit of uncomfortable aspects that you bring in your space. And there are also systems which provide little bit of reduction in energy that gives a medium energy, but continues to provide you a high energy, high comfort in your spaces. So depending upon the application that you have, you can select that where do you fit in this box in terms of comfort, how much comfort compromise you are willing to make for your occupants, how adaptive they are, and accordingly select the appropriate low energy cooling system for your building. Now, if I relate that with saying that, what would be the energy impact of a certain type, this is a simulation studies showing that if you use an India model of adaptive thermal comfort in your design, you can achieve for all system types 15 to 30% energy savings. So it's not only selection of AC or a low energy cooling system, but how do you operate makes a significant impact on the energy savings. So using an adaptive model allows you to operate at a higher temperature, indoor temperature, still maintaining a comfort, and achieve 15 to 30% energy savings. Another very important strategy that we typically use and is widely used is the air velocity. We have found that the occupants in India and in the tropical places, tropically acclimatized occupants, have a preference of higher air velocity. So during our studies of the thermal comfort of occupants in our comfort chamber, we have found that you can maintain a slightly warmer temperature with higher air speed and still keep people comfortable. So increased air speed and increased air velocity can lead to maintain a slightly elevated temperature in tropically acclimatized occupants. So this is a strategy I think we should definitely use in our residences as well as in all buildings throughout India. As part of the research project, we have done an extensive validation of these strategies. So we developed a CFD model for ceiling fans using the actual measurements, and that helps us in validating some of the low energy simulation tools. Why it's important? It's important because when we start using it in providing inputs to the professionals, we actually start utilizing this knowledge and making a more robust estimate of what the savings would be, what are the benefits in the comfort, and what are the benefits in the energy savings. So these are the 4 strategies that we have identified as a part of the research project. And as you can see, it's directly linked with what are the different components that we have in our spaces. So living rooms, master bedroom, and small bedrooms, you may have windows and dampers that will allow air exchange between indoor and outdoors, ceiling fans, mechanical cooling. If you have an additional system like mechanical ventilation or dehumidifier, you would actually use a little bit more sophisticated ventilation and cooling strategies. So based on the components that are installed in the spaces, we have also identified as part of the research project different ventilation and cooling strategies that one should use in them. And then For example, if you have only window and mechanical cooling, then you would use a simpler strategy of ventilation and cooling one system, strategy one. But if you have all the components, you would actually go for a more complex operation of ventilation and cooling strategy 4. And this all strategy has been built into a control architecture, because ultimately how we operate these components after designing determines our energy savings, our performance, as well as comfort of the occupants. So we have spent a tremendous amount of time looking at the control architecture and different control algorithms that should be used for mixed mode buildings. And what would that control? It would control whether first selection of mode, whether the building should operate in natural ventilation or air conditioned mode, or it should continue to operate in mixed mode, and then control each of the components, whether we should turn off, close the window or keep it open, or turn on the ceiling fan, as well as operate the system set points. So integrating all that into the control strategy is what we are proposing as part of this research project. We have done an extensive validation of these strategies using a CFD simulations and an experimental chamber. So this is an experimental facility that has been used to validate these strategies and control algorithms. It's a state-of-the-art facility located at SEPT University. And you see in the bottom picture here, there is a room within a room concept. So where you have an outside room and an indoor room. In outside room, we maintain outdoor condition, and in indoor room, in outside room, we maintain outdoor condition, and indoor room, we maintain indoor conditions. And in between, we operate this natural ventilation dampers here to assess whether the strategies that we are proposing, how effective those strategies are. By using those strategies and a validation experiment results and a simulation model, these are the results that we have found. That if we do the analysis for 4 cities in Ahmedabad, Bangalore, Chennai, and New Delhi, you will see that we can, by using different complex strategies, we can increase the saving potential from 24 degrees to 35 degrees. So more components you have, more opportunities you have to save energy. And it works in all climates. You can see that you can save energy even in Chennai, New Delhi, Bangalore, and Ahmedabad. So in a very, very diverse climate also, you can achieve a significant energy savings. So what are the key conclusions of all this research project? The key conclusions that we have found is that mixed mode control strategies and a good designed buildings can provide 12 to 55% energy savings in different climate zones in India. And I think that's why it's very important to now take it and apply it and use the help of architects like you to use this strategy in the real buildings. And what we have also found is that there is a good agreement between simulation and experimental results that has been validated in our validation chamber. So we can say that the strategies that we are proposing as part of the research project is very, very robust and can be used in the real world with good amount of confidence. I know that I've browsed through a lot of information and different steps, but this is also documented in a low energy cooling and ventilation design guide that we have prepared as part of the research project. You can go ahead and on this website and download for free this design guide. You just have to register for free, and then you will be able to download and understand all the detailed steps. And feel free to reach out to us if you have any questions or if you need any support. With that, I thank again SRM Institute for organizing this wonderful conference and for inviting me to the event to share our findings of the research project.
Thank you, Dr. Kumar Shukla, for your insightful presentation. I am sure that the audience have found it to be a very informative presentation. Now we shall take a short break for our sponsor video, post which we shall proceed to our next speaker.
Welcome to the course Color Psychology. The first module, The Background of Color, will give you an overview of multiple perceptions in color. We will learn about the scientific background,
I have scientific proof that white light is composed of 7-component colors.
Understand basics of color theory. Take inspirations from colors in nature.
Context matters, you know.
Teleport to different time zones to get historical perspectives of color.
Is Greek architecture devoid of colour? Isn't it completely white?
And finally, dig deep into the human mind to get psychological perspectives of color. We will then go on to explore color in various spatial typologies of architecture and interiors. A transition from theory to practice would happen in the last module on practice and application of color. The journey would be immersive with fun quizzes and activities along the way. Join us in this colorful, fun-filled journey.
Hey!